Greetings, algebra students. This is Dr. Heron talking to you about Unit 5, Notes 2, talking about permutations, combinations, all in this big idea of probability stats. So in this case, we're kind of looking at how things kind of lay out and how things kind of get set and organized depending on how many people you have and how many things you're trying to do. So permutation, combination are just methods of counting that kind of end up shortcutting some of the work for you, okay? So now I will show you on the graphing calculator how to do this and kind of what it means, but you need to understand what the main differences are. So if I look, when a manager for a softball team fills out the order of the lineup, the order in which they fill out the names is important because that's going to also give you the batting order, the order in which the players bat. Suppose you have 7 players in mind for 4 spots. Okay, so you've got 4 spots at the top of the lineup. There's 4 spots in the lineup. You got 4 top spots in the lineup. How many different ways can 7 players go in there? Well, you have 7 choices for the first spot. Then once I make that choice, I've got 6 players left, and out of those 6 players, that's going to go in the second spot. Then after that, you're going to have 5 left there, and then you're going to have 4 left for that remaining spot. Okay, so that's just going to be 7 times 6 times 5 times 4. So for that option, for those 4 spots, you've got 840 possibilities that can go there, okay? For 840 different possible ways you can do that. So a permutation basically means order is important, okay? BA and AB are going to be 2 different things, okay? So a permutation looks like this. If you go into your graphing calculator, your TI-80, whatever, if you hit the math button and then scroll over to PRB, that means probability, and then go to number 2, that is your permutation, okay? So what you're doing is you have n choices and you're taking away r. So if I look, that's like the okay? So if you have 10 finalists in the figure skating competition, how many different ways can you award silver, gold, and bronze? Permutation of 10, choose 3. So that's gonna be like 10 factorial over 10 minus 3 factorial. So that's going to be like 10 times 9 times 8 times 7 all the way down to 1 over 7 times 6 times 5 times 4 times 3 times 2 times 1. So when I do that, I'm going to get 720. So there's 720 different ways that can be awarded. Okay, but the order matters. It matters if you get gold, silver, bronze. So a newspaper has 9 reporters available to cover 4 different stories. How many ways can reporters be assigned to cover the story? So first story is different than the second story is different than the third story is different than the fourth story. So the order matters. So it's going to be like 9P4, okay? Sometimes said it's like 9 comma 4. So it'll be 9 factorial over 9 minus 4 factorial. So that's going to be 3,024 ways. Okay, so all you're doing is a lot of factorial work. This did not come up very well. This says geometry. So now, how does this work? Well, how many different ways can I rearrange the letters? And the way this works is I don't really care if it makes a real word or not. I'm just rearranging the letters. So how many letters do I have? 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 letters, so I'm going to start with 8 factorial. Okay, so that is my number of letters. Then on the bottom is where I put repeats. Okay, so you can't tell me, you can't tell the difference between 2 of the same letter. Okay, so I've got 2 E's in geometry. So I'm going to put 2 factorial down there. That's going to be for the E's. And let's just see if I have any other ones. No other G's, no other O's, no other M's, no other T's, no other R's, no other Y's. So that kind of becomes my problem, okay? So it's just going to be 8 factorial divided by 2 factorial, or just 2. So there's 20,160 ways you can rearrange the letters of geometry to get, just to reorder them. One sec. Yep. Okay. So now, if you have permutations with repetitions, so you end up doing that. You end up doing your factorial on the top and then all of your repeats on the bottom. So this is the word Mississippi. The river, not the state. Just kidding. That doesn't matter. So on top, you've got how many letters? 4, 5, 6, 7, 8, 9, 10. You have got 11 letters on the top. But now you have got 4 of the same letter. Okay, you have 4 of the same I's. You have 4 of the same S's. And then you have 2 P's. Okay, you can't tell the difference if they're rearranged, if the S's are in a different order. They're all the same S. So they're all also the same I. You can't tell them apart. So this is going to be kind of how I solve it. So I'm going to take 11 factorial. I'm going to divide that by 4 factorial times 4 factorial times 2 factorial. So that ends up being 34,650 different ways. Okay. Now, this should not say permutations. This should say combinations. Okay, this should say combinations. So combinations are where order doesn't matter, okay? A grouping is a grouping is a grouping, okay? So you're thinking about groups of things. You're not thinking about orders of things, all right? So when you go, you are going to look at this, okay? So it's going to be the same n factorial, then n minus r factorial, but then you multiply by another r factorial. So you think about it as like n choose r. So in a combination, Jim, Susie, and Sally is the same thing as Susie, Sally, and Jim. You're going to have more of a permutation. And this is your standard deck of cards. And for those of you that are unfamiliar, there are 4 suits. So you have clubs, spades, hearts, diamonds. There are 13 of each. There are 26 black cards, and there are 26 red cards. There are 12 face cards. Okay, these are all your face cards. And 4 aces. So just kind of be aware of what some of those things are when we start to talk about this, okay? So now we start talking about combinations. Let's do it. 7 students are working on a project and 2 students need to present. So it doesn't matter if you're picked first or picked second, you're still going to be a presenter. So this becomes 7 choose 2. So this becomes 7 factorial over 7 minus 2 factorial times another 2 factorial. So 7, 6, 5, 4, 3, 2, 1 over 5, 4, 3, 2, 1 times 2 times 1. So it's going to be 7 choose 2 factorial. So there's 21 different ways, 7 kids. You can pick 2 out of 7. Choose. Okay, 5 cousins are at a family reunion. They decide 3 of them are going to get pizza. How many different ways can they do it? So you've got 5 choose 3. So it's going to be 5 factorial. So 5 times 4 times 3 times 2 times 1 over 5 minus 3 factorial and 3 factorial. So 5, 3 So you've got 10 different ways. So 5 cards are chosen from a standard deck of cards. How many hands consist of 3 clubs and 2 diamonds? And means I'm going to multiply them. So 3 clubs, so you have 13 clubs, you're choosing 3. Okay, it doesn't matter what 3 you're getting or the order, you're just getting 3. Then you've got 13 diamonds as well. 13 diamonds to choose from. So you're going to take 13, choose 3, and that's going to be 286. And you have 13, choose 2, and that's going to be 78. Then you're going to multiply those because you have to get both. So you're going to get 21,736. Oops, I messed that up. It's 276 times 78. So that is incorrect. So it should be 22,308 ways. So if 6 cards are drawn from a standard deck, how many consist of 2 hearts and 4 spades? You're going to do the same kind of thing. So you're going to take 13, choose 2, times 13, choose 4. So that's going to be 78. 13, choose 4 is going to be 715. So it's going to be 55,770 different ways. Previous one. All right, last one, 6 cards. How many hands consist of 2 cards from one suit and 4 cards from another suit? So this is a little bit different, okay? This is a little bit different because I'm not designating one suit. I'm not saying they have to be hearts and diamonds. I'm not saying they have to be spades and, diamonds or anything like that. Just 2 of one suit, 4 of another. Well, 2 of one suit is going to be just 13 times 2. And 4 of a different suit is going to be 13 times 4. So we just did that one. So that is going to be the 55,770 ways that we just had. But that's for specific suits. So now I need to take that. I've got 4 choices for the first suit. And then once I make that choice, I've got 3 choices for the second suit. So I'm going to take that and I'm going to multiply it by 12 because 4 times 3 is 12. Because that accounts for all of the different possible suits. So that's my answer, 669,420 ways to do that. Okay, so a lot of calculator work, but you have to set up the numbers correctly and put and make sure you have things in the right places. Come talk to me if you are struggling with the calculator or if you need help with anything else, and I look forward to your questions.